Okay, so I just wanted to find some problems. I didn't find very good problems right now. I need to look further, but at least I can give you one. You can think about it yourself, and then in the meanwhile I look for the other better problems. So if you finish with this one, we can start that one. So it was a little bit surprising for me when I saw the problem myself. So assume that you have a square. Let me try to draw it properly. So, yes, so assume that you have a square here. For example, from 5 to 50 here. So you have this square. Yeah, something like that. It is not 100% precise, but it's good, reasonably good. So you have this square, any square that you like to draw, it doesn't matter. That's the interesting part. And then you choose any point that you like on DC, any point, it doesn't matter. For example, let me choose, just random point, E. Let me call this one E. And then what I do, I connect this point A to this random point E that I have chosen here. And then what I do, I draw the bisector of this. Might be it's a good idea because might be you get confused. So let me draw it in a way that is clear. This is not the bisector. So let me choose another, let me choose this point, for example, a little bit here. It doesn't matter, of course, but I just think it's easier for us to visualize. Yes, I connect this point A to E. And then what I do, you see there is an angle here, angle EAB, this angle I am talking about, yes? I want to bisect this angle into two equal pieces, yes? How should I do that? So, yeah, let us just do it, somehow I don't have different colors here. No. I don't know where is my red pen. Okay, so it doesn't matter. Let me just do it with the black again. So I try to draw the bisector. So, and then this bisector will go and intersect this side. Let me call this point F. So what I'm saying is that, for example, if this angle is alpha, this angle is also alpha. I want to show that, or means prove that. It is really interesting. It doesn't matter where do you choose this point. If you do this bisector, it will connect this one. If you add BF, which one was that? BF plus DE, it becomes AE. So it was a little bit surprising for me first I saw the problem, but when I was able to solve it, I realized that this is true. So it doesn't matter where you choose this point. Of course, if you choose the point close or far, this angle will be different, and this angle bisector would be different line segment. But if you find the intersection point and measure the size BF and measure the size DE, if you add BE and DE together, it becomes exactly equal to AE. independent of your choice of this point. So at least, is the question clear? Yes or no? Is the question clear? Hello? Hello? Okay, so let me also describe this question. I think I give you time to think about them and I solve them and we are finished probably. So in this problem, this bigger triangle, of course this picture was hard to draw precisely, so this is not to scale, but it's understandable. So you have this triangle, the big triangle is an isosceles triangle, AB is equal to AC. On top of that, we know that BX is equal to BY and is equal to AX. It's not very good in my picture, I couldn't draw better than that, because I have to keep this angle to be 10 degrees. So the angle YBC is 10 degrees. I know that BY is equal to BX is equal to XA. I know the bigger triangle is isosceles triangle. This angle is 10 degrees and I want you to calculate the measure of angle X. Okay, so that's also another problem. If you are done with that one or you are getting bored from this one, we can also work from here. So yeah, I think at 1 o'clock I will start solving them for you. I can give you a hint for the first problem and then give you 5 minutes more and then we have to start solving them. So let me write them a little bit below. This was C and this was D. The trick here that I found is to do this. I will continue this line. I mean, it took me also a while to discover that this might work. So you see this line on the square, I continue it from this side with these dotted lines, this dotted line here. And what I do, I measure this, whatever it is, I separate that length here. For example, because to make the picture right, so let me measure somehow. This is nearly 27, so I will get this one. So for example, so you understand what I mean. So what I did, I continue. You might say, why? This is the method that I discovered. Might be you can find a different way. So there is no definite answer why I did this, because if you are patient, you will see that this will solve the problem. So I just continued that, and then in this continuation, I chose a point, let me call it M, which is not already in the problem. I chose this M in a way that length dm becomes equal to bf. This is always possible, yes? I continue this line segment from this side, and then whatever it is, I measure that and separate this point, and then find this point, so that from M to D is equal to B to F, from B to F. And after that, what I do, I will connect these 2 points together. So that was the hard part. Actually, it took me a while to discover that this way will work. Okay, so let me just put a dash here. So let me put double dash here. So this length is equal to that length. And then I connect this to this one. I think this will help you. This was the hard part. I'm not saying the hard part. This is the hard part of my solution, to discover that this method will work. Might be you are also finding a different method. So I want to pause the video again to give you a little bit of time to see why this method is useful for proving this. And then I will come back to you and solve this, and then solve the other one and end the meeting. Thank you.
Babak, did you mean to pause it?
Pardon? No.
Yeah,
thank you very much. Okay, now let us start solving the problem. Couldn't you come up with any kind of idea for this problem?
Okay, so I have one idea.
Yes?
The triangle you drew, AMD, it's congruent to triangle ABF.
Okay, great. Can you tell me why?
Yes, so we already know that BF is equal to MD.
Yes.
And we also know that since it's a square, then AD will be equal to AB.
Exactly.
And we know that the angle is 90 degrees, so we have the side angle side, I think it's called, which is proof for congruency.
Yeah, exactly. So let us just do that. So whatever you said is completely right. So this is one of the non-trivial applications of congruency. So I just drew this one equal to this one, and then connected here to this one. There is no guarantee that this triangle is an identical copy of this triangle unless you can show it. And the way that Rocco mentioned it is completely correct. He said that I myself made this part equal to this part. This is the way that I did it myself. And then I told you that this quadrilateral is a square. It is given in the problem. So it means that I already know that the size of AD is equal to the size of AB. And if this is a square, this means that this angle is 90. So this angle is 90. It means the adjacent one is also 90. So exactly right. Thank you. So this triangle here is congruent to this triangle there. So let me write it down patiently. So here, let me add AD is equal to AB, and let me write angle, for example, let me call it angle D1, not to get confused. So angle D1 is equal to angle B is equal to 90, exactly, based on side, angle, side, and you see that these are two sides, and this is the angle between these two sides. So everything is in order. Then it means that the triangle that I just constructed right now, MAD, is congruent to the triangle ABF. Okay, so that is good. Okay, but how can I understand that this can be helpful? Look at here what you want to prove. You want to prove that BF plus DE is equal to AE. You can go to a scratch paper. AE is AE. but instead of, so DE is also DE, but instead of BF, I can put DM. This is a scratch work. Okay, so this becomes DM. But then I look at my picture. What is DE plus DM? It becomes EM. Yes? And my goal is to show that EM is equal to AE. So it means that I have a second goal now. Instead of proving the main problem, it is enough to show that ME is the same as AE. It means that if I can prove that this bigger triangle here is an isosceles triangle, then I am done. So then it means that I start concentrating on proving that AEM is an isosceles triangle. So if I want to show that this is an isosceles triangle, I need to work on this angle and this angle. Okay, so I think you see that I am transferring the problem into another problem, so that suddenly I can solve the problem. Okay, so I am trying to concentrate on this angle and try to see if I can convince myself that this angle is indeed equal to that angle. If I can do that, then I am done. I hope that you agree with me, because let me just repeat. If I can show that this angle is equal to this angle, this means that the length of AE is equal to the length of ME, but ME can be written as MD plus DE, and MD is equal to BF, so it becomes BF plus DE, and then I am done. And I think we have some enough information, because I know something that I haven't used so far. I know that these two angles are equal. So, for example, can you tell me what this angle is? What can I write for this angle here? Or so let me see if that is necessary. Yes, I think that is necessary. We need... No, might be it is not necessary. So let us see what happens. So let us concentrate. First of all, let me ask you this angle. Can you say something about this angle because of this congruency? This angle you see, AMD, so this implies that the angle AMD is equal to which angle, can you tell me? Based on congruency. This angle from this triangle?
Should it be AFB?
Exactly. So this becomes this angle.
Yes, exactly.
So this becomes angle AFB. But can you tell me what is AFB in terms of alpha? You see, this is a right angle triangle. If this angle is alpha, so what is this angle then?
It's 180 minus alpha minus 90.
Which becomes 90 minus alpha.
Yes.
Yes, so that is 90 minus alpha. If that is 90 minus alpha, this is also 90 minus alpha. Because they are supposed to be equal. How should I know? Because of congruency. So, at least I have something for this angle. Let us go back and see this angle. This angle is composed of two parts. Yes? This angle is composed of two parts. One this part, one this part. Yes? Can you tell me what this part is?
It's alpha.
It's alpha because yes, they are congruent. So this is alpha. But now can you tell me what this angle is? Don't look at here. What is this angle?
90 minus 2 alpha.
Yes, exactly. 90 minus 2 alpha. Why? Because the whole angle is 90. It's a square. 2 alpha is gone here. So what is left for this is 90 minus 2 alpha. Now let us take it back. I want the contribution coming from both of them. So what is the total angle now? This angle is alpha. That angle is 90 minus 2 alpha. I add them. Minus 2 alpha and alpha. It becomes 90 minus alpha. So what can I write for this angle? I realized it is nothing except 90 minus alpha. What is this angle? Exactly 90 minus alpha. So this means that this triangle is an isosceles triangle. It means that ME is equal to AE. But ME is MD plus DE. Instead of ME, I put MD plus DE is equal to AE. But instead of MD, I can put BF. So this becomes BF plus DE is equal to AE. So you see, this is a non-trivial application of congruency. So we just continue. This one was the creative part. I was also myself confused for some minutes. So I don't know, might be you can cook up another method which doesn't rely on congruency or something, but this is one of the easy ways that came to my mind, so that if you want to prove that. So you see, this is completely a proof because it is independent of what I do for E. If I change the place of E, of course AF will change, but this result will remain intact. So that would be the result that you get here. Okay, so I hope that you enjoyed the problem. So you see that geometry problems could be really hard. Could be really extremely hard. They can be extreme. But it is a very nice exercise for the brain. If you want to improve your creativity, I would recommend you to try to find some problems. I think mind your decisions. Of course, it needs a lot of knowledge in geometry, but mind your decision is one of the... So I think, I don't remember, it might be you can Google it. It is a YouTube channel including a lot of nice problems, and there are many nice mind your decisions, I think. Decisions. So something like this. This is the name of the channel. So you can find a lot of YouTube channels talking about geometry. I really recommend you in the summer, every now and then you can just work on a geometry problem, okay? So this will give you the opportunity to improve your creativity level. Okay, but I don't think that should be hard. I don't know, Cameron, so did you got the correct answer? You are still believing that this should be 45? Because I don't know, according to the answer in the book, this angle should be 40. Anyone else?
Okay, so Cameron gave me the explanation, so I'll explain if he doesn't want to.
Yes, you can explain.
Yes, he gave me what he wrote, so I'll just write out what he wrote.
Yes.
Yes. So he says angle B plus angle C plus angle X is equal to 2 times angle X plus angle X sub 2, I think he writes.
I don't understand the notation. So you mean angle X plus?
I don't know exactly how he's thinking, but I'm just saying what he's written.
Okay, so that would be hard for you to explain unless he himself is willing to explain.
Okay, so Cameron, kan du faktiskt förklara över din hjälp? Cameron?
Might be he's not here, but
I'm trying to get Cameron's attention.
yeah, okay. So let me to solve it, because we have only 5 minutes. The way that I want to solve this problem, just come with me if you confirm that. This angle is I am looking for. Do you agree that if I call this angle X as well? Yes or no?
Yes.
Because BX is equal to AX. So this, yes, this is equal to this one. Because these two are the same. If this is X, of course I don't know X yet, but if that is X, that is also X. Okay? Now, what I want to write, so how did I do this? Let me check. Okay. Now this is the tricky part. I call this 2x. Do you agree with me or not?
Yes.
Why is that? Who is saying yes?
The same. It's a wicked sunset.
Yes, it is the exterior angle. Yes? So this 2x, this angle that you see, is an exterior angle. Let me draw this here. For example, this is A. I don't know, this is X, and then this is B, and then this is what I am talking about. Do you agree that this angle is an exterior angle for this triangle? This angle is X, this angle is X, this angle is supposed to be the sum of these two internal angles. So if this is X, this has to be 2X. And then now I want to write 2X on top of this one as well. Do you buy it or not? Yes, because bx is equal to by. So if this is 2x, this has to be 2x. Yes. But now what can I do? I can see that 2x, if this is 2x, this is 2x. Can you tell me what this narrow angle is? This triangle, this angle plus this angle plus this angle should be 180. But this one plus this one is 4x. So what is left for 180 minus 4x? Yes? So you see, what I did, I took this to be x and I wrote everything inside this triangle in terms of my unknown x. So if you ask me how many unknowns I am dealing with in this problem, I would say that I have only one unknown, and that is exactly what I am looking for. Okay, but how should I do that? Here you see that if I ask you what is the sum of these angles, it is x degrees plus 180 minus 4x, yes, plus 10 degrees. If I ask you what is the size of this big angle, hopefully you agree with me, this is the size. This is the size on the one hand. On the other hand, I haven't used one piece of information yet. I haven't used this at all. I have used this, and that here, but I haven't used that piece of information yet. There should be a reason that they have given that to us. And now it becomes clear. Why? Because the bigger triangle is an isosceles triangle. So it means that if you ask me what is this angle, I can calculate it for you in another way. I can say that I calculate 180 minus x and then divide it by two equal pieces because this angle and that angle are the same. Yes? So I calculate this and then divide it by 2. If I ask you what is given here, you would say this is again the size of this angle. So you see, I use this information to find that this angle is this. I used another piece of information provided by me in the problem to show that the size of that angle is also this. But this is the size, these are the sizes of the same angle. So they cannot be different, they have to be equal. So this means that 180 minus x divided by 2. And this is just not geometry, this is a simple Math 1C equation. And I need to solve it. And then I don't like fractions, so I multiply by 2, so it becomes 2x. I multiply this by 2, 360. I multiply this by 2, minus 8x. I multiply this by 2 is 20. And then I multiply this by 2, 2 is gone, so it becomes 180 minus x. And then I try to solve this equation. So let me just do most of it in my head. So minus 8x here plus 2x is minus 6x. I move minus x to the right, it becomes positive, it becomes minus 5x. This one and that one is minus 6. I move it here, it becomes positive, so it becomes minus 5x. What is left for numbers? 180. I move 20 to the left, to the right, it becomes minus 20. And then I have this one, I have to move it to the left, it becomes minus 360. Hopefully that I have done everything right. So it becomes minus 5x. 180 minus 20 is 160. 160 minus 360 is minus 200. And then I am looking for x, so I have to make x alone. I divide by minus 5. It becomes exactly the answer in the faucet. At least I don't consider this a coincidence, because the answer in the faucet is 40, and I was able to get the 40. So you see that this, yes?
Just one question. How did you get 180 degrees minus x divided by 2?
Yes, let me explain this again. So let me clean this. So this is the skill that you need to improve. So forget about what is inside. If you do not look what is inside, you will get this. This is an isosceles triangle. These two are the same. So for example, call this alpha. This is also alpha.
Yeah.
So, and then alpha plus x is 180, yes? So 2 alpha is 180 minus x. But alpha is half of this expression.
Alright.
Yes. So you see, this was a nice problem. These are a little bit higher level problems, because you calculate a quantity in 2 different valid ways. If you are calculating the size of something in 2 different valid ways, you cannot get different answers, because you are calculating the size of the same thing in 2 different ways. So I calculated the size of this angle using these pieces of information. I got this. I calculated the same size, but this time using this piece of information, I got this. It cannot happen unless these 2 quantities are the same. And the rest of it is not geometry at all. The rest of it is algebra. Algebraically, I solved the equation and I got this x equals to 40. And I don't think I told you that the solution is not in the book, but the faucet tells you that the answer should be 40, and I think this is reasonable. I cannot consider this a coincidence. So might be if the answer is 45 in Cameron's method, either he has made a mistake in the solving equation or in its logic. Okay? We can just go through that together to see what happens. Okay, so let me just stop the video. Thank you. I will upload this video later tonight.